Chapter 4. Basic Geometrical Concepts. In the previous class, we have learnt about basic concepts of geometry such as point, line, line segment, and ray. Let us first revise them and then study them in detail. Detailed study of point, line, line segment, and ray. Point. A point is an idea which is represented by a dot. It is named by a capital letter of the English alphabet. A point has no length, breadth, height, size, and shape. It only has a position. Here, 2 points X and Y are shown. Line. A line is a straight path of points which can be extended to any length on both sides. A line has no endpoints. It has no definite length. In the figure shown alongside, AB is a line. Remember, practically we are unable to draw a line on a sheet of paper. We can draw only a part of a line and put arrowhead on both sides. We can represent this line as AB, line AB, or BA, line BA. Sometimes a line is represented by a small letter like small l, small m, small p, small q, etc. In the figure shown below, small m is a line. Line segment. A line segment is a part of a line. It has a definite length. It is named by using capital letter of the English alphabet. In the figure shown alongside, AB is a line segment. A and B are endpoints of the line segment AB. Clearly, a line segment has 2 endpoints. Ray. A ray is a part of a line having one endpoint and extending endlessly in other direction. The endpoint of the ray is called its initial point. In the figure given alongside, PQ is a ray. It starts from its initial point P and passes through Q, extending indefinitely in the direction of Q. PQ and QP are not the same rays. They are 2 different rays. Plane. We come across various objects or things having flat surfaces in our daily life. The surface of a paper, the face of the blackboard, screen of a flat TV, floor of a house, top of a table, etc. are all flat surfaces. In mathematics, a plane may be defined as follows. A plane is a flat surface that goes endlessly or extends indefinitely in all directions. A plane has no boundary, that is, we cannot draw a plane on a sheet of a paper. We can draw only a part of plane. We draw figures such as square, triangle, rectangle, circle, etc. in a place. So, we call them plane figure. Remember, a plane is a collection of an infinite number of points. We can name a plane by writing any 3 points on it. The above given figure shows plane ABC. Parallel and perpendicular lines. Parallel lines. Look at the pairs of straight lines shown below. In figure 1, lines PQ and RS intersect at point O. In figure 2, when line PQ is produced towards the point Q and line RS is produced towards S, they intersect at point O. In figures 1 and 2, lines PQ and RS are intersecting lines. In figure 3, lines PQ and RS on being produced on either side do not intersect. Such lines are called parallel lines. The distance between the parallel lines always remains the same. Thus, parallel lines can be defined as the straight lines which lie in the same plane and do not intersect or meet at any point on being produced on either side. If lines PQ and RS are parallel to each other, we write PQ parallel to RS. The symbol means is parallel to. The opposite edges of a scale, a table, 2 tracks of a railway line a blackboard, etc. are physical examples representing parallel lines. Line segments can also be parallel. In the given figure, line segment AB is parallel to line segment CD. Perpendicular lines. Look at the lines PQ and RS shown below. In figure 1, lines PQ and RS intersect at point O to make 4 angles. In figure 2, lines PQ and RS intersect at point O. When produced, they form only one angle. In figure 3, lines PQ produced and RS intersect at O. In this case, 2 angles are formed. We measure all the angles formed in the 3 figures. We will find that each of these angles is 90 degree or a right angle. When 2 lines PQ and RS intersect in such a manner that each of the angle formed is a right angle, they are said to be perpendicular to each other. If lines PQ and RS are perpendicular to each other, we write PQ perpendicular to RS. The adjacent edges of a tabletop or a book, the adjacent sides of the walls of a room, a telephone pole standing on the pavement are some practical examples of representing perpendicular lines.